Hi, this is Ilka Cassidy with Passive House Accelerator, and thanks for tuning in to the special bonus episode of the Passive House podcast, recorded at the International Passive House Conference 24 in Innsbruck, Austria. And a big thank you to Source 2050 for their support of the series. In this episode, Anna Czerwinska talks about her project, a deep retrofit of a 1960s school complex with prefabricated straw bale on an occupied site using multiple Passive House certification approaches.
Hello everyone, my name is Anna Czerwinska. I'm a Polish architect working in France since around 10 years. And I'm an architect and a Passive House designer. And in my work field, I specialize, actually I do only Passive House, new builds and retrofit projects. And it's true that recently we do more and more NRFit and retrofit projects, and we focalize a lot in the non-residential buildings, just like the school projects.
So how many projects have you done before you started this endeavor?
I did 3 projects four, sorry. And one of those projects was NRFit. It was a school. But unfortunately, the client decided, it was designed as a Passive House project. But when the client saw the price of the triple glazing windows, unfortunately, he decided to go with a double glazing. So in the end, we couldn't certify the project. But it was my first experience of renovation, school renovation on occupied site.
Okay. So tell us a little bit about the school complex that you worked on.
So this school complex, it consists of 2 schools. We have kindergarten and we have an elementary school. They were both built in 1962. The floor area of both of them, it's around 1,500 square meters. And they both had very poor indoor quality, no ventilation. The kids were suffering from very high temperatures in the summer that would go above 26, 7 or even 8 degrees Celsius, and very low temperatures in the winter that could go below 19 or 18 degrees Celsius. That was also caused by the fact that the school had to do some savings in the energy bill at the moment of the energy crisis in Europe.
And where's the school located?
The school is located in the city of Saint-Étienne. It's in the central part, you could say, of France. It's not far from Lyon. And
you approached the different buildings in different ways.
Yeah, so the client, the investor, he asked us to renovate the existing buildings, but also he said that he needs more space. So we knew that we will do this huge part, which would be the NRFit, but then we'll also do extensions and we'll make them as energy as efficient as possible. And then also he needed a new multi-purpose hall for different activities like sports activities, extracurricular activities for the kids. So we did one completely new building, which is a Passive House Classic building. And then the extensions, they are the extensions of the existing building, they are considered as NRFit. And for this project, the initial idea was to make all the new construction a timber frame construction and using straw bale as insulation. But unfortunately, when we did the first cost analysis, the calculations, we realized that the budget that we have doesn't let us do only timber frame and straw bale, which is unfortunately today very expensive in France, as it takes more time and manual work to do the straw bale pieces. And what has the highest taxation in France is for manual work. So this is why it's expensive, even if the material is natural and it's provided locally. The fact that there have to be more people who have to work more hours to build the element, it makes it more expensive. So, but anyway, we said, okay, we cannot afford that the all new construction is a timber frame and straw bale, but let's make a compromise. we decided to make one small extension of 75 square meters and a straw bale one. And then the other new buildings were a mixed construction, so concrete and a bit of wood.
And I'm curious about the straw bale approach. So that was prefabricated.
Yeah.
And where was it prefabricated?
Yeah. So we have the way the building sites are organized in France is that we have a lot of companies, and we had one company which was responsible for everything that was made of wood and all the prefabricated wooden elements. So them in the workshop, it was a very good company who already has got some previous passive house experience. It was the only one that we had that had this previous experience. They have the workshop, and they build a kind of wooden cases, and then they have the local straw bale providers. They buy the straw bale, then they fill the wooden cases, and then they have the whole fabricated element that arrives on the building site, and then the mounting of the wall goes very quickly, and then they just apply the airtight membrane. They can do it either in the workshop or on the building site. In the case of my building site, they did it in the workshop, which makes that it's much more precise the way it was done, and we are sure that to have an airtight construction. This is a very good material. We try to use as much as possible, but as I said before, unfortunately, it's still an expensive one.
And in terms of working with it, since you did both strategies, one a little bit more conventional and one with the straw bale, how did both compare?
We have to keep in mind that the straw bale would be, as I said before, more expensive. It takes more space because the cases, usually they are 38 centimeters wide, sometimes 42. In the case of the passive house, you know that you will need additional exterior insulation to cut all the thermal bridge of all the timber elements. You would need internal insulation, or at least some kind of void to put all your installations. So for sure, the thickness of the wall, the final thickness would be above 40 centimeters. So that's a lot. You need to make sure that you can afford, that you have the space, and that, yes, that's possible in case of your project. And then for sure, the airtightness. I mean, you need, with concrete, you're quite sure that the construction will be airtight. It's easy. Here you have few elements, it's wood. So you need to make sure that your airtightness layer is well done. It's continuous, that you have all the sealing tapes well done. It's a bit more technical.
Yeah. And then you were talking about some other strategies. One was that you implemented geothermal.
Yeah.
And then one interesting approach was that you used robots to insulate the crawl space.
Yeah, we have the existing kindergarten and elementary school. They both were built above a crawl space because in the 60s in France, it was a very typical way of building. I think they have a lot of radon. I don't know if it's called radon in English, but they have a lot of radon gas in the earth, in the soil. And that's why I think they were building a lot with a crawl space. So according to French regulations, we couldn't let people go inside the crawl space to work. It was just like 50 centimeters height, the height that we had. So we knew that we'll need a robot. Either we use a robot or it's not possible to do it. So, we took us some time to find a company which would be able to use this robot, to use this technology. It's not at all common in France. Maybe I'm not far from truth if I say that maybe we're the first one to do that in France. But those works were subcontracted to a British company. So I had British people coming to the building site and doing those works for the French, something that we didn't expect, but it proves how uncommon it is.
Yeah. And it should be common, right? Because it's a very common
and it should be
way
common.
to
And
build,
I saw other projects that were like the roof and the walls were very well insulated, but then the crawl space, the architect decided not to insulate it because they thought that it's not possible. So this is how, otherwise it would be a great project, really energy efficient, except for the part where they said, no, we cannot insulate the crawl space.
Yeah.
So I'm happy that, okay, we're the first one that did it, and maybe it will be easier for the next ones.
Yeah. So interesting. So while you're doing all of this, the school stayed occupied.
Yeah.
How did you do that?
Well, we knew that the works would take around 12 months. So it was out of question to make the school empty. It was out of question to do it just during the holidays. But also we were lucky in the case of this school. I think that it wouldn't be possible for every project, for every school. In the case of this school, we knew that the management of the school, they told us it is possible for us to relocate some of the kids. It was possible for us, so we can, for example, we can take one part of the building, which is 3 classes. You renovate this part and we will put the kids somewhere else and it will be fine. We informed the parents and they were okay with that. So you can renovate this part and then you can move on to the next one. And also, it was difficult to explain it on the podcast, but you saw the floor plan of the school. It was easy. It's like a letter Z. So there was like the northern part, central part, and the southern part. So we could really divide them inside. And we had also 2 bathrooms, one bathroom the northern part and one bathroom on the southern part, the toilets. So kids, we could close one part and kids, they still they had another toilet. So it was a typology of the building. The fact that the management of the school told us, okay, this is what we can do. Otherwise, we would have to use modular containers and relocate kids in those containers, which wouldn't be great, I think. It would be an additional cost. So here, and of course, you have to make sure while you work in certain parts, and then there are kids just behind, where you put rigid fences, you make sure that there's no noise, you try to eliminate or reduce the noise during the noise of works during the classes. You try to reduce the fact that the dust would spread to another part of the building. Also, the good thing is that in France, on Wednesdays, the kids aren't at school. So Wednesday was the day that we said, okay, the heavy works, the most noisy, we do them on Wednesdays.
Okay, good thing.
Yeah, but you have to. It was a very good collaboration with the management of the school. Otherwise, I guess it wouldn't be that easy.
Yeah, and is it finished now?
We will be finishing the building site this summer. We are almost finished. I would say like 80% is done. 80% is done. We did the first air tightness tests for some parts of the school. The results are very good so far, but we still have some tricky places that we're still not like really. We know there are some goals that we have to fulfill, and there are still some places where maybe we'll need put some additional work to make them airtight, etc.
And have you gotten any feedback if it feels much more comfortable now, or is it not?
Not yet. It would be very important to hear from the users. So far, it's been only 1 or 2 weeks that it started to be warm. Previous week were quite cold in France, and the problem that we saw was that the user, let's say, the user behavior, they have trouble. Before they would put their heating like maximum to have, because they were cold, and they even though the school is renovated, they continue to do that, which makes sometimes it was really hot inside those classes when we entered. So we were trying, I think it's an additional work to tell them you don't have to do that. I think that they will see by themselves that they don't have to put the heating really high to be comfortable. but still have trouble adapting to the new school, to the new environment.
Well, it's probably going to take a while until they really learn. I mean, you basically have to learn the building, right?
And adjust it. You have to learn the building. Yeah. But for example, for the exterior shading, we have some, I don't know if I'm speaking English, but it's captors. We have like exterior small machines that know that it's automatic. Okay. So when we know that when we have a lot of sun, the screen shades would go down. Okay.
Is it connected to the weather data?
Yeah, it's connected to the weather. If there's strong wind, they will go up. But generally, if there is a lot of sun in the summer, in the warm months, they would go down. So it means that the user doesn't have to do much, and it will be automatic, which makes sure that there will be no overheating in the summer.
Yeah.
For example, in the winter.
So in general, how is the Passive House standard being adopted in France?
I would say it's still in the phases where it's not very well known. I would say it's developing much better in the northern parts of France than in the southern parts. We start to see, we have a few public buildings which are passive houses, and then we have some private investors who want to make their house a passive house. But I would say general knowledge among architects and those who make policies is very low. France, they have got their own certificates, and they would rather go for a French certificate than a German one. But what is developing well is the wooden construction in straw bale. I would say that biological materials really developed well. People appreciate the fact that their house will be built with materials that are local. They really appreciate the fact. This is the good point. The energy efficiency is less developed, I would say, and also the kind of conception of, for example, mechanical ventilation, it has got rather bad. People think it's not something good to have mechanical ventilation or very airtight construction. They would be more like, no, I want a house that breathes, kind of this way of thinking, which is a little bit, I mean, this is how we used to think 50 years ago. Yeah. But about the materials, I can see that it's developing quite well.
Yeah, so it sounds like there needs to be a little bit more education on the side of the population, that they just understand the Passive House standard a little bit better.
And architects as well.
And architects, yeah. So this morning at the keynote, we heard that, you could look at Passive House as the 42, which is a reference to the Hitchhiker's Guide to the Galaxy, where 42 is the solution to everything, to the universe, to everything. Do you agree with that statement?
First of all, I haven't seen the movie. I must be like the only person there who hasn't seen the movie. But I think it's a little bit like democracy. It's not perfect, but so far we don't know anything that works better. I was very glad to hear this year, I think it's the first time that I'm hearing it that much, that they start to focus on biological materials and using locally produced materials and the lifespan of the products that we use.
Great. Thank you so much, and congratulations for this to this amazing project. That was definitely very impressive to see.
Thank you very much. Thanks for having me.